Okay, so this is going to be part 2 of our Explore number 4 discussion. Let's go ahead and continue with our notes with Roman numeral 3. And we're going to talk about volcano types. If you recall from some of the pictures I showed of you when I was in Mount Lassen, I was on it wasn't a shield volcano. It wasn't a stratovolcano or a composite volcano. It was this type here, cinder cones. And so let's go ahead and start from the top and try to understand the differences between all these volcanoes, okay? What are they? How are they different? They differ by their, and I'm going to pull my pen out here, they differ by their shape, their size, and the way that they form, okay? So over here we'll say volcano types vary, that means they differ based on shape, size, and how they form. The first type we have is a shield volcano, letter A. These are, as you can see, highlighted here largely. They're large, they're densely sloped volcanoes that result from the eruption of basaltic lava. Let's go ahead and write that down. That's going to be good, okay? They're large, gently sloped, and the result of basaltic lava. Okay. Remember, basaltic lava is largely uncontaminated. It does not have a lot of silica or water or sodium or other things. So this stuff should be pretty low in viscosity. It should flow pretty easily. And that's why it can flow great distances. See, that flows great distances before cooling, and it's because it's basaltic. Okay, so you should always be trying to make connections as you work through your note taking. Okay. The more viscous the lava extruded by a volcano, the less distance it flows from its source. Volcanoes with viscous lava form dome-shaped structures that are called lava domes. Okay, so this seems to be a qualifier. It's not a different type of volcano, but we should put down versus, okay, versus lava domes. Which form dome shaped structures. Okay. And why don't they form the typical volcano with nice gentle slopes? It's because they have more viscous magma due to more viscous lava. Okay, therefore it doesn't travel very, so it doesn't flow very far. Okay, all right. Moving on to our text over here, you can see a nice picture there of a shield volcano. Moving on to composite. Composite means to be made up of things. In parentheses, they say stratovolcanoes. And in the text, they're going to talk about why they call it strato. It's because it's made up of different strata, different layers. All right, so let's put down letter B. Composite volcanoes, aka strato. Okay. As far as description is concerned, they are large mountains with steep sides and a distinct cone shape. This is your classic volcano shape, right? Steep sides, we can draw this if we want. Okay, there you go. If you go over to the left side here, they're formed by alternating layers of intermediate lavas and pyroclastic materials. Okay, so if you're wondering what are the layers that make this up, we could draw that just to kind of give you an idea. We'll say here, made of layers. Lava and pyroclastic material. Pyroclastic material. And you remember what pyroclastic material is, right? It's going to be ash and dust, right? And make sure you read the rest here because they just talk about these having steep slopes because of a higher viscosity, right? Higher viscosity. So the lava is fairly viscous. That's why it forms more steeply. The same way that a dome doesn't flow very far, right? Because it's thicker and then it dries. Same thing for your composite volcanoes. Okay. All right, and that moves us on to the third type. This will be letter C. This is going to be your cinder cones and spatter cones. Okay. When compared to other volcanoes, cinder cones are small. Right? They often look like stratovolcanoes. They're steep cones of pyroclastic material that have formed when lava, rich in gases, is blown violently out the vent. Okay, so they don't have as much flow versus they're kind of constructed by this stuff just erupting out violently. A cinder cone, therefore, usually has a central bowl vent surrounded by volcanic ash and lapilli. So we can say here, cinder cones, small, often look like stratovolcanoes. They are steep and made of pyroclastic material, which was violently ejected. Right? They have a central bowl vent. Okay, now if you run down then to the next section that we've highlighted here, and again, read this whole thing there. They're going to give you some examples. When erupting lava contains enough gas to prevent the formation of a constant lava flow, but not enough to explode the lava into small fragments, it forms a spatter cone. Okay, so a spatter cone seems to be somewhere in between. Okay, I'm going to write this spatter cone. Okay. These guys form when the erupting lava contains enough gas to prevent formation of a constant lava flow, but not enough to explode lava into small fragments. Okay, and thus it's going to form what's called a spatter cone. Okay. All right, got just a couple more topics to talk about. Calderas, if you can take a look at this picture here. This is up in Northern California. Imagine that the volcano used to have a top, and it emptied all the magma from underneath it, and so it collapsed and formed a giant bowl. And now that bowl has filled with water. And this is what they call a caldera. Okay, so let's write that down here. I think this is going to be maybe Roman numeral 3 or 4. That's going to be Roman numeral 4. Okay, so caldera. Write this in black here. Roman numeral 4. Caldera. Okay, what about them? They form when a volcano collapses into its magma chamber during an explosive eruption. Okay. The collapse enlarges the crater of the volcano and fills in the crater with collapsed materials, often filling with material over time. Okay, so we have our crater lake in Oregon over here. Okay. And finally, the last thing that we need to talk about is something that looks, performs like a volcano, but is not a volcano. And these are called your fissure eruptions. Roman numeral 5. Fissure eruptions. And if we were to really quickly just take a glance over here, these are pictures of fissure eruptions. Okay, they happen along the faults. They didn't form a volcano, but you can certainly see that the lava is erupting out of these long fissures. Okay, these are called fissure eruptions. Okay, sometimes non-explosive eruptions occur along fissures or cracks in the Earth's surface. This event is common in rift zones, such as mid-ocean ridges, where the crust is splitting apart. Okay, so let's write that down there. Sometimes non-explosive eruptions occur along fissures in the Earth's surface, i.e., at divergent plate boundaries, which are spreading apart, right? Such as rift zones